So going in depth, the schematic overview of animation, as seen in the intersection, we can see here the skeletal mesh, the skeleton, again, tied to the skeletal mesh, to the sequence, and to the anim graph. The anim graph separated in event graph and anim graph, and all the sequences and all the things that we can do with sequences will go directly into the anim graph. And also we can generate procedural animation, also goes into the anim graph, and we can control the flow, and again, that goes into the anim graph. Then we have the control pose, and we will see that we can do several things with the final pose, with the calculated pose. And then in the rendering side, we have some tools to change the performance of that.
And just to clarify on the naming as well, because if we're talking about sequencer and sequences are two different things, just not to mix them up.
Animation sequences.
So these are animation sequences, which are the actual animations, not the sequencer cinematic tool.
Yeah. We're not covering this in the animation class. So to begin with, how the skeleton and the skeleton mesh are related. First of all, just so you know that when you import an FBX file into Unreal, what you have is, imagine that you have done an animation, several different animations in a file, in the same FBX file, and you have also the skeleton, like the rigging, and you have the mesh. So when you import that, you're going to have several different files, not just one. You're going to have the skeleton, and tied to the skeleton or linked to the skeleton, we're going to have the skeletal mesh, that is purely the geometry, and then the different animations that we have done in each one in a different file. So that's how we relate all this. And also, when imported, we can also generate a physics asset, okay, that is going to define how that skeleton can react to physics environments. So for each skeleton, as I have said, and we're going to see this in the engine, we can have several different skeletal meshes. And if we go, for example, for our main character, and I select the mesh, we can see the skeleton here. I'm going to show the bones. So this is purely the skeleton. The skeleton is the hierarchy of those bones and how they connect to each other. This is the list of the bones with other things that we will see later. And we can see that we have several meshes tied to the skeleton, okay? And that's that binding that we have here. Also in the skeleton, I'm going to zoom in, we can have different things like virtual bones. We can create our own hierarchy inside the editor. It's as simple as creating, for example, here, a virtual bone, and you select the parent. So you can skip several steps, for example, if you want to simplify a chain of bones. And you can also add sockets to some bones, and that will a socket is an element that is parented to another bone, and it will follow its transform all along the animation. That is useful, for example, to attach certain things that we want to handle from gameplay to a skeleton. So, for example, if we want this character to handle something, we will create a socket in the hand, and then we can change that object through gameplay, totally separated to the animation. So that's almost everything related to a skeleton. Though one important thing is that we can, as we can see here, we have a system called retargeting manager that will allow us to all these assets that we are linking to the skeleton, like the mesh, or the animation blueprint, to assign them to another skeleton. So with this, we can see, we can picture it here. Retard manager, using the retard manager or retargeting manager, or even if we go to an animation, even selecting one of these animations and going to the content browser, we can select it, duplicate it, and retarget to another skeleton. So we can use that animation in a different skeleton. Usually the skeleton has to have more or less the same structure and be preferably very similar to the skeleton that we use as a source. So in the skeletal mesh, we are not only storing the information of the polygons, we also store material information. I'm going to hide the bones. Select it only. Material information. But also here, we can manage the load system. So we can use these settings. Here in the reduction settings, we can set these settings and click regenerate load, and we will have different meshes depending on the distance that we are rendering it from. And also, well, some of the settings, like what physics asset are we going to use and such. But another important thing is that the clothing is stored also in the skeletal mesh. And then if we go to the sequences, as I said, animation sequences are the different animations that we have assigned to the skeleton. We can import, as we saw, the animation sequences from a file, but also, once we have imported, we can use LiveLink, that is a plugin that we have for different DCCs, to lively make a change in that DCC and pre-visualize it directly in the engine on runtime. The sequences, we can see here that we can have a lot of them assigned to the same skeleton, and on them we have a timeline. Here we can play it forwards and backwards and sets, but also we have some metadata associated to them, and we can combine them together in different kind of assets. For example, the metadata that we can have are animation curves. And this, for example, if we go to the jog animation, I'm going to select jog forward, we can see here several curves that show the, several curves that we can use for different purposes. Like, for example, if we remove root motion from an animation, we can calculate the distance that is that animation should be walking. So we can use that from gameplay. All the metadata that we put in on animations can be read lately in the event graph, and that can be passed to gameplay. Also, for example, we can add notifies that are special events that, for example, we can use to tell gameplay that something is happening. For example, in a combat system, when I swing a sword, for example, the hit will be the moment that I want to check if it's hitting something, for example. And then I can notify a gameplay blueprint that is happening in that exact time. And also, a special kind of anim notify that we have are sync markers. Sync markers are pretty special because, for example, we have this here. This is telling us that when something is happening and we're marking this, right plant, left plant. With this, when we play another animation, for example, jog start, should be a start here. Yeah, jog forward start. This will allow us to put those markers together. Traditionally, we should have the same length for the loop than for the start. And then it can be blended together because otherwise the feed will sleep. But by doing this, the engine is going to try to match those plants, the left plant with the left plant and the right plant with the right plant from those different animations. And it's going to stretch or squeeze the animation that is not the master to the master length, okay? And that's done, for example, in the anim blueprint. If we, like for example, have an animation here, in the sync group, we say who's the leader and what group name, like what sync markers are we going to use in this animation, okay? So that's the metadata that we can have on animing sequences. Then we have some assets that come from animation sequence that we also have in this list that are the blend shapes and the montages. For example, we have a montage. The montages are a way to group or combine different animation sequences together, for example. I like to picture it as the anim cues, sound cues when you have sound waves. And this is related to the sound, but it's basically how you can combine several different assets of one type into a group. And those are easily playable from gameplay. So anim montages, for example, are usually played in, depending on the input of the character, and will be reactions usually. Typically, they will be reactions of the character, like when the character is hit, when the character lands, and that kind of things, instead of played as a flow, as something that comes in the flow of the character. And the other ones are the blend spaces. Blend spaces are a way of blending together nicely two or like several animations that depend on two variables or well, 2 dimensions of variable or one dimension. I think we only have this is, for example, one dimension. So what we have here is that we are blending between 2 animations depending on the value of this variable. And as we can see here, those are the different values that this variable can take. It can go from minus 45 to 45. And this will change the angle of the character as she is running. I don't think I have a, let's see, all those are, yeah. This one, for example, it's 2 dimensions variable. So we have the slope, and also we have the lean angle. So to see it better, when the slope, it's depending on the angle, when the angle is positive and when the angle is negative, we will blend in together those animations. And we have each point in this blend shape is a different animation. So we are blending all those depending on those different variables that we can set here the values. And what else? We have, and also we have a different kind of asset that is a pose asset. I don't have an example of that. Pose assets can be created easily from an animation. For example, I can pause and create asset and create a pose asset, okay? And that will grab this pose of this animation and store it in a different asset. And with those different poses, I can blend them together again to create a new animation. So for example, if I want to create a new jog animation, I can create the different steps of the animation. I can create pose assets and blend them together, but I can control them using gameplay variables, for example. So I can control timing from gameplay and sets. And that will be everything regarding animation sequences. All those sequences at the end are things that we can play in the anim graph. And let's take a look at the anim graph. The anim graph is this asset that consists in two parts. I'm going to go to the root. The event graph. This is an example of an event graph. In the event graph, we will process all the variables that are external to the animation. Okay, so we are going to be feeding the event graph from the gameplay blueprint or C++, whatever. We will be grabbing all those variables, transforming them in our own variables, and with that information, we will control the flow of the animation in the anim graph. As you can see in the anim graph, we start in this node, but we can follow the flow that is calculating this animation till the final pose here. Okay, so we start here, we continue here, then we continue here, and we are processing the animation and depending on the variables that we have grabbed in this event graph. An example of the event graph, we're getting the pawn, we're monitoring if it's falling, she's falling, and if so, we set a variable that is in air. And then we will use that information to play a different flow, depending if it's, for example, jumping, we will consider this on air, and we will enter in that state instead of keep jogging, for example. In the flow, we will have a lot of different types of nodes. Main ones are going to be the state machines. State machines are pretty useful in this kind of setup, but it's not only it's not the main tool that we're going to have to select the flow of the animation. So though they are very quite powerful at the end for like high-end animation flows, it's not enough to have only state machines. Even if, for example, here we can have a state machine inside another state machine. So in state machines, we're going to have different states like idle, jog start, run, jog stop, and we will be transitioning using Blueprint scripting language to decide what state we should be in, using the variables that we can see here that we have been gathering from the event graph. But also we have other kind of nodes where, for example, and I'm going to go into the kind of nodes that we can have here. This is, as I said, the anim graph, the flow control nodes. Okay, the flow control nodes are, sorry, these ones. We have slots, and these are quite tricky to get at the beginning. A slot is something that, as the flow comes in, if I stored something in this slot, I'm going to override the flow by that thing that I put in the slot. So for example, I'm using that, we're using that for storing anything that is a reaction. So every time the player hits, for example, attack in this case, it's going to store the montage of attack into that slot. So that is going to be stored here, and it's going to be overreading any animation that I'm playing that is coming from the flow, and then outputs that animation. But if in gameplay I didn't store anything in this slot, nothing is going to be changed in that flow, okay? Then, for example, we have the cache node. Post-caching means that we store temporarily, we store that position that the flow has, and we can retrieve it. For example, we are storing this in upper body, then we are retrieving it in upper body, and what we are doing here is that we are blending what we had in the upper body, for example, an attack animation, we are storing the attack animation, and we are blending that with whatever we are doing in here in the locomotion pose. So, for example, if I'm running animation will come here, but here I have an attack animation. Then I will blend, in this case I'm blending from the hips upwards, the attack animation with the running animation. And if I don't put anything in the slot, I will be blending the same animation with the same animation, so there's no problem, okay? And we have different types of blending. Blending is interpolating between bones, so two animations get mixed together. We can blend by different kind of variables. For example, here we're blending just by a value, but here we're blending depending on a Boolean. For example, this is the condition for blending for this node, but we also can use additives. And additives, instead of trying to mix in two animations together, it's putting an animation over on top of the other one. So, for example, if we have an animation that is being hit, and that pushes the chest, for example, a bit backwards, I can play that animation on top of anything that is happening, because it's kind of a reaction that I can add to the animation that is already happening. So that will be an additive animation. But also, as I said, we can do kind of procedural animations or animations that depend on physics. For that, as I said, we have a physics asset. Here, we're going to have a look at the physics asset. I'm going to open the one, well, yeah, the one for the minions, so you have an idea of how it looks like. It's in the mesh. So this is a physics asset, and as you can see, we have capsules that are physics representation, how the body should behave. And we have here in this graph how those bodies connect to each other. Those are the constraints that will define how those bodies have to react on what is the change between those bodies. So, for example, if I hit simulate, we will see how those react in a physics environment. And with this, what we have is that we can blend, using these nodes, we can blend physics behavior with the animation that we're running. So this will again modify the flow. As you can see, all those have an input flow and an output flow, and will change the behavior of the animation depending that physical setup. The rigid bodies connect to the physics asset, and usually we will have a physics profile, physics animation profile to define all those constraints. We can do it here, but also we can do it in an asset called physical animation profiles. And later we will see why that is important. But also in the anim dynamics, we can do it per bone instead of using the rigid body setup. Okay, and also we have inverse kinematic nodes that will allow us, for example, to try to make a change react, like try to meet one target that we want with a chain of bones. And we are using this, for example, in the case of the main character, to always have the feet in the proper position. No, the capsule, just a static mesh. In the blueprint and the anim graph, at the end of everything, we're using the leg key to fit to place the fit in the proper position, in a position that it's not going to depend on anything that is happening before. Okay, so that's how we layer. Those are all the tools that we have to layer the animation and to modify the animation. And before going to the final calculated pose, I also want to add two things. We have animation layers. This is pretty new. It's in experimental state yet. But animation layers allow us to create small pieces of behavior, small ways of controlling this flow. And for two reasons, we can switch between one of those depending on gameplay input or any kind of variable, but also we can work together, like two animators can work together in the same anim graph using animation layers. One will be working in one of the layers and the other one will be working on another layer. And regarding controlling the skeleton, we have Control Rig. Control Rig is a tool to be able to basically make a rigging inside the engine. So with this, for example, we can create behaviors between that depend on different parts of the chain of the skeleton. For example, we can use we can create ways of controlling the fit depending on the hip position and that kind of things. But also at the end, it's as powerful as we can create a whole rigging system inside the engine and be able to animate that inside the engine. Regarding the final pose, so once we have the final pose that we can see at the end of this flow that we mentioned, what we can do with this pose is one, we can share that pose among different skeletons. So if we have different characters, like not different characters, we have the different characters that use the same skeleton and the same skeletal mesh, we can share the position, like the pose of one of them among all of them, okay? But we can do it in a very refined way. So for example, we can calculate only 4 of them and distribute all those 4 poses among hundreds of them. So we are only doing the CPU to process 4 of them, and then we are sharing that among a lot of them. That's very good for like crowds and publics and that kind of things. But also we can record what is happening in the animation with the sequence recorded. We can see it here. It's pretty easy to do. So for example, if we go here, window, cinematics, sequence recorded. This used to be around here, but it has changed to cinematics in the latest version. And we hit play. And I say I want to add the player, and I want to record it. I just have to hit record. I can move around. Well, it's let's see if I can do things, move around. Okay, and I hit stop. And then that has been recorded in an anim sequence that I can see here and playback. So I'm going to stop. So I can check if the animation, for example, is blending well, if, well, just speed up the mouse a lot.
That's my speed.
Yeah.
Let's change the...
Yeah, no. Okay. I know, with the wheel. So I can repeat everything that happened to the player anytime I want. So not only it's good to check if the animation is behaving properly, but also, for example, I can do that with simulations. I can throw several boxes and record that, and instead of being simulating that every time in runtime, I can play an animation that does that and doesn't have to calculate all the physical implications that creates. So that's what we can do with a calculated pose. And regarding performance, animation is, depending on what we do, can be quite heavy, but we have several tools that we can use to reduce the impact of that. One is the animation sharing manager. We have a lot of skeletal meshes going on, but like we have the animation budget allocator, that it's an amazing tool that will allow you to set a budget of time that you want to spend in animation. And if we're going to go over that setup budget, it will cut features, so we stay in that budget. So for example, it will reduce the amount of ticking of those actors, of those anime blueprints. It will share animations. It will cut on physical behaviors, that kind of things, to keep that budget established. We also can reduce how much the animation is ticking. We can have, as we saw, LODs, but the LODs don't only reduce the amount of polygons. They also reduce the amount of bones that a character has. So for example, again, if I go to the mesh and I visualize all the bones, and then, for example, we go to the hands and I change the LOD to the 4, you can see that there's no bone for the hands anymore. So if I have I'm playing an animation that is grabbing something, that animation in the distance, the character won't grab anything. Like the animation won't be grabbing anything, but in the distance it doesn't matter. So we also have fast path nodes. Most of the nodes that we use in the animation blueprint, in the anim graph, have this kind of anim bolt here. That means that is not that is used as if it was purely compiled C++, instead of having to process a lot of things like in Blueprint. That is played like native C++. So it's going to be much faster than the nodes that don't have this line involved, like, for example, this one. So taking that into account will reduce the performance, the impact on performance for animation. And also, we can ask the engine to work on animations in multi-threading. That is like that can be save a lot of time if we have a lot of threads idle. But if not, it will run in the same way as having one thread. But so you know that you can also activate multi-threaded updates.